Hello students, welcome to PVK chemistry classes. I am very happy to meet you all through this video, especially for 11th standard students. This video this lesson is useful for Tamil Nadu State Board 11th standard students, CBSE and ISC board students. So, fundamentals of organic chemistry. Up to the class 10, you are learned chemistry under the science subject. From this higher secondary classes, you are studying chemistry in a separate subject, chemistry as a separate subject. So, the first and very basic lesson of organic chemistry is the fundamentals. First, we know the fundamentals of organic chemistry. Organic chemistry plays an important role in day-to-day life as well as many industrial manufacturing process. The word organic means life. So, we can identify or we know that the life existing process is based on the organic chemistry or organic compounds. Carbon plays important role in organic chemistry. Carbon plays an important role in organic chemistry. This life existing process, especially majority of the complicated biomolecules are exist in the form of carbon and its compounds. For example, vitamins, proteins, lipids, carbohydrates, nucleic acids and energy existing process, energy storage or energy existing process, that is glycogen, and all are exist in the form of or containing carbon as one of the major component. So, organic compound plays an important role in our daily life also. How these compounds are arrived? What is a simple history for this organic compounds? In early 1828 or early the 19th century, peoples are believed that, or scientists or chemists are believed that organic compounds are synthesized from naturally existing materials, either plants or animals. Organic compounds are synthesized from living things. This concept was supported by Berzelius-Vittel-Post theory. What is the major concept of Berzelius-Vittel-Post theory? The Vittel-Post theory pointed out organic compounds synthesized from plants and animals by a certain kind of force called Vittel force. This theory is pointed out or called as Vittel-Post theory. And scientists believe this concept after the proposal of, after the identification of urea from urine of mammals by Henry Frederick Wöhler of German scientist or German chemist. He synthesized urine, urea from urine of mammals, and also synthesized the urea from inorganic mineral origins. So, what are the inorganic mineral origins used for the synthesis of urea? Is ammonium sulfate. Ammonium sulfate. Ammonium sulfate reacts with potassium cyanate in the laboratory. It gives the compound called ammonium cyanate, NH4CNO plus potassium sulfate. This is the first reaction, ammonium cyanate. Once this compound is formed, ammonium cyanate is formed, this compound on rearrangement gives urea. The formula for urea is NH2 CONH2, urea. This is the proposal of or the identification or the find out finding this compound from the laboratory. After the middle of 19th century, the great blow about the Whittle-Post theory. So, after that, majority of the organic compounds are synthesized in the laboratory. For example, in 1845, Cole is a scientist prepared acetic acid from the elements. Acetic acid is also exists in the form of natural materials. It also synthesized in the laboratory from their elements. And 1828, Colonel prepared ethyl alcohol. 1856, Berthelot prepared methane, etc. So, the middle of 19th century, Whittle-Post theory was completely discarded. Whittle-Post theory was completely discarded. So, this is the beginning or the beginning theory of this organic compounds. So, now we are going to discuss, so what is organic chemistry? How organic chemistry important in the chemical field or plays a nominal role in chemical field. Organic chemistry is a study of carbon and its compounds. Simply defined, organic compound explains the study of or explains the carbon compounds. In addition to carbon and hydrogen, or simply say carbon and hydrogen are said to be hydrocarbons. Organic chemistry is a study of hydrogen and carbon compounds or hydrocarbons. Simply say hydrocarbons. In addition to carbon and hydrogen, other elements such as nitrogen, phosphorus, sulfur also included in organic compounds. Therefore, in modern terminology, organic chemistry is defined as chemistry of hydrocarbons and its derivatives. Chemistry of hydrocarbons and its derivatives. This is a simplest and modern definition of organic chemistry. What is organic chemistry? Organic chemistry is a study of carbon and its compound or carbon and its derivatives or compounds of derivatives. Then what is the valency of carbon? The valency of carbon, you know the valency of carbon. The valency of carbon is 4. How this valency of carbon 4 is arise? We know that carbon atomic number 6, electronic configuration 1s2, 2s2, 2px1, 2py1 and 2pz0. So, look at this valence cell electronic configuration, totally 4 electrons present in the valence cell. Therefore, the valency of carbon is 4. Carbon need another 4 electrons for attaining stable octet electronic configuration, or the valence shell consists of 4 electrons are removed to attain the stable electronic configuration. Simply say either add 4 electron to their valence shell or remove 4 electron from their valence shell. This is highly impossible because it requires lot of energy to add 4 electron in their valence shell. In the same manner, removal of electron also very difficult. It requires it needs higher amount of energy. That is the electron affinity and ionization energy are the two factors needs in the case of arising octet electronic configuration. Therefore, carbon in their valence shell or carbon and the 4 electron present in the valence shell shared electron with other compounds or the other carbon compounds to form a chain of covalent bond. So, carbon mostly are form covalent compounds. How these covalent compounds are formed? Covalent compounds are formed by the mutual sharing of electron with neighboring carbon atoms or other elements. Neighboring carbon atoms or other elements. Therefore, the valency of carbon is 4. So, the formation of methane, how the methane is formed? Carbon valence shell consists of 4 electron. Each hydrogen atom valence shell electron consists of only 1 electron. So, carbon and its 4 electrons are mutually shared by the neighboring hydrogen atoms. It leads to the formation of the simple organic compound called methane. So, tetravalency of carbon. Tetravalency of carbon. And also another important property shown by this carbon compounds are catenation. What is catenation? Catenation is a property or unique property shown by this carbon. Carbon has easily formed chain of covalent bonds with other carbon atoms. This property is called catenation. Carbon self-condensed with other carbon. Carbon self-condensed with other carbon to form a chain of covalent bond, that is called catenation. Why carbon shows the greater catenation power? Because of their stronger bond length, stronger carbon-carbon single bond length and high energy, carbon bond length and higher energy. This is called a catenation. Now, the important characteristic property of this organic compounds. What are the important characteristic property of organic compounds? Organic compounds are covalent in nature. Organic compounds are covalent in nature. We already known that how the covalent bonds are formed. Covalent in nature. And these organic compounds are non-polar in nature. Non-polar, not easily polarized. Therefore, the organic compounds are highly insoluble in polar solvents like water. Organic compounds are insoluble in polar solvents like water. But organic compounds are readily soluble in non-polar solvents, especially benzene, ether, chloroform, etc. These are the non-polar solvents. Organic compounds are non-polar, therefore non-polar readily soluble in non-polar solvents. Organic compounds are highly inflammable except this carbon tetrachloride. Highly inflammable. You know, flammable, inflammable and non-flammable. What is inflammable? Inflammable means easily catch fire. Easily catch fire. Therefore, these compounds are easily catch fire, hence it is called as inflammable compounds. Organic compounds greater tendency to shows isomerism and it easily undergoes polymerization. Isomerism. What is isomerism? This concept is discussed in later classes, as well as now simply what is isomerism. Isomers, the same molecular formula but shows different structural formula. Same organic compounds having the same molecular formula but differ in their structural formula, that is isomerism. Polymerization, the compounds are easily undergo polymerized. Polymerization is a large number of single monomers combines together or bind together or join together to form a big giant molecule, that is called polymer. The process is called polymerization. So, these are the some characteristic properties of organic compounds, and also it contribute homologous series. Now, what is homologous series? What is homologous series? A class or group of organic compounds related to each other or related to one another and expressed by a general molecular formula called homologous series. Organic compounds contribute the homologous series. For example, the alkane series. All alkanes shows the general molecular formula CnH2n plus 2. All alkanes shows the general molecular formula CnH2n plus 2. Alkenes, this is alkanes. Alkenes shows CnH2n. Alkynes CnH2n minus 2. Alkynes, alkanes, alkenes and alkynes. Alcohol ethers. CnH2n plus 2O. CnH2n plus 2O. This is a general molecular formula for alcohols and ethers. So, this contribute homologous series. Now, what are the important characteristics of homologous series? All the members of homologous series must having same elements. Suppose we are taking alkane means all the members of homologous series having carbon and hydrogen only. All the members of homologous series are prepared by similar methods. Similar methods. Suppose one compound is prepared by hydrolysis method means all the members are prepared by the same method. All the members of homologous series are differenced by or distinguished by the group called CH2. All the members of homologous series are distinguished by the group called methylene group CH2. For example, the alkane series first member CH4 is a methane. You add CH2. The second member is C2H6. The successive members of homologous series are differed by the group called methylene group CH2 group. All the members of homologous series shows similar chemical reactions or similar chemical properties. All the members of homologous series and their physical properties, especially melting point and boiling points, are differed by or varied by regular gradation. There will be a regular gradation in variation of physical properties, especially melting point and boiling point. So, these are the some characteristic features of homologous series. The next one important topic of this organic part is functional group. What is functional group? Functional group. What is functional group? The chemical properties of the members of homologous series are characterized by a group called functional group. What is functional group? The chemical properties of the members of homologous series are characterized by a group called functional group. For more than 30 functional groups are present in the various organic compounds. Now, some of the functional groups. We discuss some of the functional groups. First of all, halogens. The functional groups of halogen is represented as X, or it is generally represented as Rx. X may be fluorine, chlorine, bromine and iodine. Halogens functional group X, it is represented as Rx. The X may be fluorine, chlorine, bromine and iodine. Alcohols, it is the general functional group of alcohol is OH, represented as ROH. Ethers, the functional group is O, represented as ROR dash. Here R is the alkyl group, we discuss later. Alkyl group ROR dash. Carboxylic acid, COOH, it is represented as RCOOH. COOH represented as RCOOH. Aldehyde, CHO, RCHO. Ketones, C double bond O, R C double bond O R dash. Ketones. Functional group of ketone is CO. It is represented as R C double bond O R dash. Nitro compounds, NO2, RNO2. Amino compounds, amines, NH2, RNH2. So these are the important functional groups you are majorly studied in class 11 and class 12. Halogens, alcohols, ethers, carboxylic acid, aldehydes, ketones, nitrocompounds and amino compounds. The amino compounds, primary amine, secondary amine, tertiary amine. Primary amino compounds, RNH2 is the primary amino compounds. R2NH is a secondary amino compound. R3N is a tertiary amino compounds. So these are the some simple and important functional groups we are studying in this classes. So now the classification of organic compounds. The simple classification of organic compounds. The organic compounds are majorly classified into two types. One is open chain or acyclic compounds. The second one is closed chain or cyclic compounds. Organic compounds are classified into two types: open chain or acyclic compounds, closed chain or cyclic compounds. The open chain or acyclic compound means mostly the compounds consist of carbon, hydrogen and some of the other elements like nitrogen, oxygen, but the chain is not in the closed manner. Therefore, it is referred to as open chain organic compounds. Closed chain compounds or cyclic compounds are further classified into two types: homocyclic compounds or carbocyclic compounds. Homocyclic compound or carbocyclic compound. Another one is heterocyclic compound. The heterocyclic compound means in addition to carbon and hydrogen, other heteroatoms like nitrogen, oxygen, phosphorus, sulfur are also present in the ring, especially furan, pyridine, etc. These are the heterocyclic compounds. The homocyclic compounds are further classified into two types: aromatic compounds and alicyclic compounds. Aromatic compounds consist of a benzene ring. The aromatic compounds are further classified into two types: benzenoid compounds and non-benzenoid compounds. So the benzenoid compounds must having a benzene ring, especially benzene, naphthalene, anthracene, penanthracene are the compounds having the benzene ring. Non-benzenoid compounds having does not having benzene ring, but it is in the closed chain. Example, so more than 6 or more than 8 carbon atoms are in the ring in the closed manner. The example for this non-benzenoid compound is azulene. The important example for this compound is azulene. And the alicyclic compounds. Alicyclic compounds are closed chain, mostly cyclocompounds: cyclopropanes, cyclobutanes, cyclopentane, cyclohexane. So these are the compounds under this alicyclic compound category, alicyclic compounds. So this is the simple classification of organic compounds. Organic compounds mostly classified into two types, that is open chain or acyclic compound, closed chain or cyclic compound. Example for open chain compounds: the butane, CH3, CH2, CH2, CH3. So, these are the basis of organic compounds. In this lesson, we are discuss the origin of organic chemistry and some fundamental aspects. Synthesis of urea by Henry Frederick Kohler and other some parameters, especially catenation, tetravalency of carbon and functional group. What is functional group? What are the types of functional groups? And classification of organic compounds. I hope all this concept are very clearly understood each and every one. Thank you for watching. Share your friends. If you have any doubts, you can ask in the comment box. Thank you.